So suppose I've got a monolayer, a layer 1 molecule thick, in a circular dish like this. And I know what the inside diameter of the dish is going to be. 99.5 millimeters. And I want to count how many molecules are in the monolayer by dividing the area of the monolayer by the area of a single molecule. So the number of molecules I'm looking for can be calculated by dividing the area of the dish by the area of a single molecule. Now, I happen to know what the area of one of these stearic acid molecules is that I'm making the monolayer out of. It's 0.21 square nanometers. Alright, well, all I've got to do then is find the area of the dish. And since it's a circle, I'm essentially calculating the area of a circle. One thing that I noticed, though, if this is in square nanometers, so is my area of the dish. And I've got my diameter, instead of being in nanometers, it's in millimeters. So, before I start, I think I'm going to turn the diameter into nanometers. And this is something that you did in the last module. You converted things with an SI prefix, one SI prefix into another. So what you did there was you took the first prefix off and then put the second prefix on. You know the relationship here. I'm sure to put the power of 10 in the right place if I always put a 1 in front of the thing with the prefix here. Okay, and now I've got to go between meters and nanometers. 1 in front of the thing with the prefix equals 10 to the, and I have to know the prefixes. Nano means 10 to the minus 9. You should be able to just rattle those off. Okay, so there's my roadmap for doing that part of the problem. Now I can turn it into a calculation. What has to go on the, I'm going to turn this into a conversion factor. What has to go on the bottom? Well, I want to get rid of millimeters, so millimeters has to go down there. There's a 1 sitting next to it there, and on the other side there's a 10 to the minus 3. So the millimeters is gone. Got to keep going. What goes on the bottom here? I want to get rid of meters, so meters has to go on the bottom there. There's 10 to the minus 9 there, and there's a 1 nanometer on top. Now I can punch that into my calculator, or I could do it in my head, okay? Because 10 to the minus 3 divided by 10 to the minus 9 is going to be 10 to the minus 3 minus 9 is 10 to the minus 3 plus 9, which is going to be 10 to the 6. So it's going to be 1,000,000 times 99.5. And I could write it out like, what? 99,500,000, which isn't really very convenient, right? So let's write it in scientific notation. I can bump the decimal place over 7 places. Okay, so now I have the diameter in nanometers. Now let's go calculate the area of the dish. The area of the dish is pi r squared from high school. Now the r is the radius of the dish. It's the distance between the center of the dish and the edge. And we're using inside diameter here because that's where the monolayer is. So this is r and this is r. So that means that I should take half of my diameter to be r. So I'm going to take my diameter in nanometers here. Now, when I'm punching this in, the parentheses are pretty important. So punch in pi, here, let's do it. Punch in pi, I have a pi key, pi times parentheses 9.95 EE7 divided by 2, close the parentheses, and then square that, and then say equals. Okay? So that's my answer. 7.77563 times 10 to the 15. What are my units? Nanometers squared. There's the area of the dish. Now, why didn't I round that off to the right number of significant figures? I mean, this has 3 significant digits. That's exact. So shouldn't I round it off to 3? No, because this is an intermediate result. You never round off intermediate results, okay? So now I know what the area of the dish is. That's what goes up there, okay? So now I can calculate how many molecules I've got. It's going to be the area of the dish divided by the area of the molecule. That's nanometers squared per molecule, if you want to put it in like that. And that way you can kind of see what the units are doing, right? Because the nanometer squared and the nanometer squared cancel out. You have 1 over molecules, which will be molecules for your answer. Divided by 0.21. It's 3.7 times 10 to the 16. Again, this is kind of an intermediate result. So I write out the whole thing and carry it through the rest of the calculations. In the problem below the video, though, they're asking you just to round it off to 2 figures, which is the right way to do it if that was your final result. So if this were the problem below this, I would say 3.7 times 10 to the 16 molecules.